Preparing the strain gauge. First of all, the required solder terminals are cut from the strip. Here, an edge of at least 0.5 millimeters must remain for insulation. With small solder terminals, the cut is made exactly through the middle between two solder pads. Tip: to ensure sufficient insulation, make the cut close to the third pad, even though it will be made unusable. Proper soldering needs a clean surface free of oxide. Therefore, the oxide layer on the metal surface can be removed, for example, with a glass fibre brush. In order to prevent contamination, all the steps are carried out on a block of clean paper sheets. When the top layer becomes dirty, discard it, and you then have a clean surface in front of you. The abraded metal and contamination are removed with an extremely pure solvent. To keep the solvent clean, the solvent is never used directly from the bottle, but instead a small amount is poured into a clean intermediate container. 2-part glass Petri dishes have proven useful for this task. The solvent is poured into the smaller dish and covered with the larger dish to prevent unnecessary evaporation. Any residues of solvent must never be returned to the bottle. The solder terminals are cleaned from both sides with a cotton bud soaked in solvent. While doing this, the solder terminals are held with a pair of clean tweezers, not with the fingers. Each cotton bud must not be dipped into the solvent twice, so that it does not become contaminated. As supplied, the strain gauges are clean, and should therefore only be held with tweezers. If a strain gauge is touched or contaminated by the fingers, then at least the bonding side should be cleaned. Cleaning can be carried out with cotton buds dipped in solvent. A completely clean underlay is needed for preparation. In this case, a clean film of cellophane is used, which is stuck to a firm base to stop it moving. The strain gauge is placed on the cellophane film with the bonding side down, and it's attached with adhesive tape. The strain gauge is placed on the cellophane film with the bonding side down. That is, the lettering is readable. A piece of adhesive is cut off. Only hold the adhesive tape with the tweezers. The yellow adhesive tape is heat resistant, and therefore it's also suitable for hot curing installation. Standard transparent tape is often used for cold curing so that the axis markings for positioning are more easily visible. The strain gauge is fixed. Here you can see the free edges of the strain gauge. The solder terminal that has been previously prepared is joined to the strain gauge so that both can be mounted in one working stage. The solder terminal must be pushed between the base film of the strain gauge and its connecting strips. so that the insulating films overlap to prevent a ground connection. The strain gauge connecting strips should then be shortened so that they terminate inside the solder pads. Finally, both parts are joined with a narrow strip of adhesive tape. Also here the edges should remain free, but the solder pads themselves should be fully covered. In addition, the two adhesive strips should overlap. The solder terminals are inserted with the tweezers between the base film of the strain gauge and its connecting strips. The connecting strips are shortened to their correct length. The prepared adhesive tape is positioned on the solder terminals and rubbed on with the back of the tweezers so that no cement can gain access to the solder pads. Please note the free edges of the solder terminal and the overlapping of the adhesive tape. The prepared strain gauge is then kept protected. For example, in the strain gauge package until it's mounted. Preparation of the measuring point. The preparation of the measuring point is carried out according to the details given in the mounting plan. This indicates the point and the direction in which the strain gauge is to be mounted. If critical, the cable routing should also be stated. The first step is to clean the bonding area. The type of cleaning used depends on the condition of the bonding point. The aim is to obtain a completely clean, easily wettable surface which ensures optimum bonding of the cement. Scrapers, spatulas and similar implements are suitable for coarse contaminants. A brush and household cleaning agent can also be of some use on severely contaminated objects. Rust, scale, paint and platings of soft metal, such as zinc, lead or tin, can be removed with grinding equipment. For our test object of bare rolled sheeting, thorough degreasing with a good degreasing agent is sufficient. The solvent must be chemically pure, that is, free from all impurities and from insoluble foreign matter. First of all, coarse cleaning is carried out with a cellulose pad, which is wrapped around the tweezers and soaked in the solvent. This is how it can be done. Place a small pile of cellulose pads to hand. Use tweezers with rounded points to prevent injury. The pads have a grain which you can see if you hold the pad up to the light. Hold the pad with the tweezers in the direction parallel to the grain and roll it up. The pads cannot be rolled in the direction across the grain. When dipping the pad in the solvent, the fingers must not dip into the liquid, since otherwise the solvent will become unusable due to the grease dissolved from the skin. Each pad should only be dipped into the solvent once, because otherwise it will become unusable. Cleaning should not be restricted to a too small an area around the bonding point. It must wash away all particles of dirt and grease from the mounting area. Any strain gauge cement needs a certain surface roughness to achieve the maximum bonding strength. For this reason, and also to remove layers of oxide that are always present on bare metal surfaces, the next stage is the roughening of the surface. Emery cloth with grain size 220 produces adequate surface roughening for the Z70 adhesive. The previous degreasing stage prevents grease from being rubbed into the surface during roughening, which would then make it very difficult to remove. Roughening with a circular motion avoids directional bias and abrasion channels. Channels running in the same direction could form the starting points of permanent fractures under a continuous dynamic load. The metal dust caused by the roughening is tapped off and the dirty paper removed. The rest of the dust is washed off with pads generously soaked in solvent. The dust must not be just evenly distributed with slightly moistened pads, a practice which is often seen. In the third stage, a cross is made at the point stated in the mounting plan. A scribe is not used for this task, since it would only cause marks in the surface and could damage the test object. A ballpoint pen in which the ink has run out produces clearly visible lines under moderate pressure, but without leaving harsh channels. If the pen still contains ink, then the ink must be completely washed off the test object using solvent, because otherwise the bonding will be impaired. The final cleaning which now follows must be carried out extremely carefully. As previously, a new pad must be used for each stage of cleaning. Finally, a fresh pad is placed to the left of the mounting point and then drawn in one sweep to the outer right. Then a new pad is placed to the right of the mounting point within the area just cleaned and then drawn to the outer left. This procedure is intended to remove any final contamination from the critical region. The bonding process should now follow immediately after this cleaning. Bonding a strain gauge with Z70 rapid adhesive. The mounting of the strain gauge should be carried out immediately after cleaning. The prepared strain gauge is taken out of its packing. If necessary, the adhesive strip is cut off with a pair of scissors along the longitudinal side of the strain gauge so that it only remains attached on one side. The strain gauge is then pulled off the film with a pair of tweezers. The tweezers should only grip the adhesive strip, never the strain gauge itself. Important: do not pull the strain gauge off towards the back. The strain gauge is now transferred to the test object. It's held by the tweezers between the two solder terminals so that the markings can be easily seen. Then the axis markings on the strain gauge are lined up with the cross on the test object. the strain gauge is fixed in the correct position with the adhesive strip. The adhesive strip should now be pulled back about 1 to 2 millimeters with the strain gauge, and the strain gauge is folded back so that the strain gauge adhesive can also be applied over the edge of the strain gauge on this side. The strain gauge is bonded with the Z70 adhesive. This is a 1-part cement in the cyanoacrylate group. Teflon film and Teflon strips are needed as aids in mounting. Please note that they must be free of fingerprints and other forms of contamination, at least at those points which come into contact with the adhesive, strain gauge, or test object. If necessary, clean them with solvent. All mounting aids must be ready to hand before the strain gauge adhesive is applied. The brief hardening period does not allow any spare time. One drop of adhesive is sufficient for all normal-sized strain gauges. It's applied to one side and then uniformly and thinly distributed over the whole bonding surface with the Teflon strip in one movement. When doing this, no pressure should be exerted on the cement. Then the strain gauge is immediately folded down with a rolling movement of the thumb. It's then pressed and held steady in this position. The Teflon film prevents the thumb from becoming stuck as well. The thumb pressure must be uninterrupted and applied over the complete bonding surface until the adhesive has cured. At room temperature, this takes about 1 minute. After the Teflon film is removed, you will be able to see a matte zone where the adhesive has bonded firmly. At points where the thumb pressure has not had an effect, the adhesive is still fluid and the surface shines. The Teflon film and brief thumb pressure are sufficient to cure the remainder of the fluid adhesive. The adhesive strips can now be removed. The cement achieves its full strength only after half an hour, and it must not yet be subjected to high loads. Therefore, peel off the adhesive strips flat and carefully in the direction of the connections. Please note that during the following stages, the area around the strain gauge should not be contaminated by, for example, fingerprints. Otherwise, the effectiveness of the later applied protection for the measuring point may be impaired. Soldering the measuring leads. When carrying out soldering on the strain gauge, a soldering station with temperature control is a great advantage. Make sure that the soldering iron temperature is set correctly. A temperature of about 250 to 270 degrees centigrade is required for the solder used here, which has a pure colophonium core. In the first step, the solder terminals are tinned and the strain gauge connecting strips simultaneously soldered. The connecting strips should not be fixed too tightly in order to prevent tensile stresses forming between the strain gauge measuring grid and the strips. When tinning the ends of the cores in the lead, the solder must be so fed that flux contained in it can transfer to the core. It's only then that the solder can flow properly. The end of the core that is to be soldered onto the solder terminal must be shorter than the length of the solder pad, so that the core insulation is still located on the carrier film of the solder terminal. This prevents ground connections forming. The soldering of the cores of the lead to the solder terminals takes place without further addition of solder, simply by melting together the two tinned parts. In order that the solder flows together, the parts must be wetted with flux. If necessary, use a flux dispenser containing colophonium dissolved in methylated spirit. The connections must be held completely steady during soldering. Any movement may give rise to a cold soldered joint. Never try to accelerate the solidification by blowing on the joint. This may cause fine cracks in the solder, leading to a permanent fracture of the soldered parts due to temperature variations. An extremely important step in the procedure is the cleaning off of flux residues from the soldered joints. This also applies to colophonium. The insulation resistance for resins can vary substantially, for example, due to temperature changes. It's easy to measure the insulation resistance between the strain gauge and the test object, but it's impossible to measure it between the two soldered joints. Only the resistance of the measuring grid can be measured there. But the insulation resistance forms a shunt to the strain gauge resistance. If its value varies, then the resulting resistance of the parallel circuit also varies, causing zero-point fluctuations, which may be erroneously blamed on the strain gauge. Any colophonium residues can only be found by a visual check. Cellulose pads soaked in solvent and held upright with tweezers can be inserted in the gap between the soldered joints. The flux must not only be washed away from between the soldered joints, but also around them as well. The surface of the colophonium is shiny, and that of the solder terminal film is matte. The complete eradication of the flux can therefore be seen easily. Fixing the leads and electrically testing the measuring point. If tensile forces on the lead are to be expected, we recommend supplementary strain relief. The X60 rapid adhesive has proved very useful for this task. A few drops of the liquid component B should be mixed to the powder component A. The adhesive should be mixed so that it's a little more fluid than for strain gauge bonding. This enables it to flow easily between the cores of the lead. Curing takes a few minutes. Once the measuring leads have been connected to the strain gauge, the measuring point can be electrically tested. First, the resistance of the strain gauge is measured. The instrument shows 120 ohms. Then the insulation resistance between the strain gauge and the test object is measured. The instrument shows more than 10,000 megaohms. That is a very good figure. The measured values for the strain gauge resistance and the insulation resistance should be recorded in the strain gauge mounting log. Protecting the measuring point. The protective covering must extend beyond the outer edges of the adhesive. With multi-layer coverings, each layer should completely cover the previous one. This dark material is the permanently plastic self-adhesive putty AK22. A small piece of AK22 is placed with the cut surface on the strain gauge and firmly kneaded, starting from the center. Only use the fingertips for kneading. Grooves pressed in by the fingernails are detrimental to the covering. After a short period, the putty adheres to the sheeting so well that solvent would have to be used to completely remove it. The cores of the lead are pressed into this layer. The other material here is called ABM75 and is also a permanently plastic compound under an aluminium film on the upper side. The ABM75 is used as a covering layer. It must be so large that it extends beyond the AK22. After removing the protective paper, the ABM75 is also kneaded firmly from the center. No cavities should be produced, and the aluminium film should not be damaged. The aluminium film should be pressed as near as possible to the metal of the test object so that the diffusion of moisture into the measuring point at the edge is made more difficult. Here, this step is made easier by using a round wooden stick. The mounting of the strain gauge is now finished, and the test object is ready for use. With the proper handling of the materials shown in this film, you will get a high-quality installation of your strain gauge with an outstanding long-term stability and low measurement errors. HBM wishes you success when mounting and using strain gauges.